So today is reviewing for the big test. The test is tomorrow. It's intense. It's about, it's called complex numbers. So let's talk about complex numbers for a minute. Are any of these complex numbers? No. Complex number is something like 4 plus or minus I. That's a complex number. Do you remember where those come from again? It's if you were factoring something, you might get an answer like 4 plus I and 4 minus I, you know? All right, so let's get back to these for a second. Which of these is factored? Well, that one is. And that one has like real x-intercepts. What would be something that wouldn't have real x-intercepts? Well, maybe if it was like a vertex form like this is vertex form. And from that, you should be able to tell me the vertex like super easy. Would you write next to it, put the vertex, put a V above it? That's sort of like a way to say the vertex is. Afton, what'd you get for the vertex? 5, -3. Good. Next, I also right away can tell from that the axis of symmetry. What's the axis of symmetry? Madison, you know the axis of symmetry? Hint, it's the axis of symmetry. It's just x equals 5. It's the x of the vertex. How many of you already had that? I just want to see if that was a common. Okay, a lot of people had that. Maybe it's just because you were on the spot. It's okay. So if you know the vertex, you know the axis of symmetry. It's just the x of the vertex. All right, and then this one doesn't seem to tell me much at all. It's not factored, so I can't get the x-intercepts. Could I get vertex form from it if I needed to? Yeah, you could do something called complete the square. But this one's kind of brutal because it's got a 3 in there, and you'd have to do half n squared, and it'd be rough. But you could do complete the square on it if you wanted to. All right, so, but what is this good for? It's that thing. What's that thing called? The y what? The y-intercept, correct. The y-intercept. Because if x was 0, do you get these two would drop out, and that would just become y equals that. And it's the y-intercept where x is 0. All right, so many little things that you need to know. All right, next little thing that you need to know is if I give you an equation, let's practice that complete the square thing. That one, if you could, you need the vertex, so you're trying to find the vertex. There's 2 ways to find the vertex. One of them is complete the square. You have to know how to do this, so let's practice complete the square. This is that deal where you go, I wish I could make it factor, so I'm going to just pick a number, move this over to make room to work. Brady, what's the half and square number?
That would be 2.
Okay, so half 4 is 2, and then?
4.
There you go.
-4 outside.
This is +4, and this is -4. Very good. Okay, and then you should be able to write it in vertex form. Ethan Hines, vertex form.
Y equals x plus 2 squared.
Take away 5, very good. Now I've got my vertex form. All right. What's vertex form good at? Give me the vertex. Why is the vertex such a big deal? Because it's the minimum, it's the maximum. It can tell you the range of the equation because like the highest it goes and the lowest it goes, are governed by the minimum max. All right. Next, you had to know so many things about factoring. Or even just solving. If I asked you to solve this, could you solve it? What do you mean solve? Well, solve it so that you find what makes it equal 0. The zeros are the same as the x-intercepts. So if I'm asking you to solve it, I'm really asking you for the x-intercepts too, but solve this. Now there's 2 different approaches a kid could take. They could either go like this, x plus 1 and x minus 1. And I say if you can factor it, you should. Because, see, I'm done already. Did anybody think of factoring it? 1 kid, 2 kids. Nice job. Maybe 3. All right. Well, what if you're doing it the other way? You're going to have a whole bunch of steps, but you can do it. Plus 1, plus 1. Draw the line. X squared equals 1. And then you go square root. X equals absolute value of x equals 1. Did you forget the absolute value? Tons of people do. Because that's what gives us 2 answers. X equals 1, x equals negative 1. Do you need this step? You absolutely need that step. Yes?
The square root of 1.
What is the square root of 1? It's 1.
Oh,
Happens all the time. People leave square root of 1 as their answer and, oh, that's right. 1 times 1 is 1. So square root of 1 is 1. All right, so there's how I did it with that. Now, that technique is good, though, because if I gave you x squared plus 6, let's make it 144. That's a nice perfect square number. Equals 0. You're going to have a hard time factoring this. I'm not saying you can't, because I actually showed you a trick way to factor it probably a week and a half ago. But if you don't think of that way, just do it the other way. You're going to get negative underneath the square root. So you're going to have an imaginary number in the answer. That's what makes it complex. Should have started by subtracting 144 and getting x squared equals negative 144. And in the old days, when you first learned square roots, they probably would have allowed you to just say that there's no solution because square roots and negatives aren't possible. But now you're smarter than that. Now you're supposed to know that it's the square root of 144, which is 12, but then you put an I on it because really what's happening, square root of 144, which is 12, and the square root of negative 1, which is what? I. So 12i. And right here, did you remember absolute value yet? Have you got that yet? It's key, because then that gives us 2 answers. X equals 12i and x equals negative 12i. Could you say plus and minus 12i? Sure. Now, could I have solved this with the quadratic formula? Absolutely. Let's look back at it and say, the only thing that would be weird about it is A is 1 and B is what? 0. Take a second because this is good to practice because the quadratic formula, definitely something you have to know for the test. Use the quadratic formula and stick in the numbers from this equation. Maybe there's no B. Yes, there is a B. It's just the B is 0. We're solving the same equation. Don't be surprised if we get the same answers. I just want you to see that the quadratic formula, why did I make that a different color than the rest of it? Because that black part is the discriminant. Very good. Okay, so anyway, use that formula, and we know A, B, and C. A is 1, so I'm putting it in these 2 spots. B is 0, so I'm putting that in these 2 spots. And C is 144. Because of the fact that we have those complicated quadratic real-world problems on it, you will be allowed to use a calculator. So this is the part where you'd bust out a calculator and go ahead and do that. I know some of you are thinking, but I already know the answers. Okay, but just take a second. You need the calculator in a minute anyway. Grab your graphing calculator or pull one up on your iPad. so things are going to happen real fast over the next few days, and I want to give you like a heads up. Even the couple kids that are absent, as long as they're watching the video, they'll know this. So tomorrow's the test, right? I will get them graded tomorrow night, period. I gotta. Because then you gotta see them on Friday. Why? Because that's the review for the cumulative test. The cumulative has the same stuff. The stuff you're just about to test on. You're gonna test on it again. And that cumulative test will either happen Monday or Tuesday of next week. I know some of you are gonna be gone. Totally fine. You can take your cumulative late. It's fine. But you have to take the cumulative. Some people think it's just a retake. Nope, it counts as a test. And it also helps you remember the stuff so that the final won't be near as hard to study for because you've been reminded about all your chapter tests. Okay, so tomorrow's the test. The next day's the review for the cumulative. And mostly, I'm not going to reviewing this stuff. We'll do that today. We're going to mostly review the chapter from before this. Know what I mean? And then Monday and Tuesday, last thought, I'm going to be gone. So it's like the perfect thing to give a sub is give the kids a choice. They can either take the cumulative on Monday if they feel ready for it, or they can sit there and review and listen to videos of like this or the yesterday's review, okay? And they can go study, and then they can take it the next day, Tuesday. But you need to take it either Monday or Tuesday. If you're going to be gone one of those 2 days, plan ahead. Take it the day that you're not gone, right? And if you miss it both days because you're going to be in Colorado or whatever, then you need to take it the following week when you come back. And same normal rules apply. Like you could take it during my class if you want. I need to take the cumulative. You just walk in the door and tell me that right off the bat, and I'll hand it to you. You take it. Okay? So take it one of those days. That's the plan for when I'm gone, is take the cumulative, one of the 2 days. It'll just be a quiet testing period both days. All right. So let's see what you got for this one. The first part's easy. It's 0 plus or minus. Well, I guess I can write 0 plus or minus, plus and minus actually, the square root of, what is 4 times 144? Negative 576. All over 2. Can I drop the 0? Yeah, I can. I can't drop the plus minus, but. And then, what is the square root of 576?
24, I think.
What is the square root of 576? 24. So now I have plus and minus 24 over 2. Oh, 24 over 2 is 12. That's where I get my plus and minus 12. And I just messed it up. Why? Plus and minus 12 isn't exactly right. What was the answer? Plus and minus 12i. So where'd I lose my way? I had a negative 576. If I'd have done a square root of a negative, I would have realized, oh, wait, this is imaginary. There it is. Okay, so there's a reminder of the quadratic formula. Next kind is just plain old discriminant. What if I had x squared minus 6x minus 1? Tell me the discriminant and then tell me how many roots this thing has. If you know the discriminant's negative, you know there is negative underneath the square root, so there's no real roots. Okay, in a moment, I'm going to ask you to compare your discriminant answer with the kid next to you, and then how many solutions it has. I'll pause while you try that. All right, so I'm having the kids write down some formulas on a note card. The two we've written down so far are the axis of symmetry and the vertex. Is there any other? Absolutely. The quadratic formula, which is right there. If you haven't already written the quadratic formula down, write it down. It'll help you have it One more time of writing it down increases your probability of remembering it. You're writing these down on a note card. It's not an optional thing. Whether you actually study with it, that's optional. Writing them, required. Here's another one for the note card. B squared minus 4AC. You see, some people, if they leave it in the quadratic formula, they think you square root it. You don't. If you do that on the test, if you square root your discriminant, I have to mark it wrong. B squared minus 4AC is the discriminant. Now, I'm going to just call it D, which is fine. Then you can make yourself a super simple little chart next to it. If D is less than 0, that's the same as saying D is negative, right? If the discriminant's negative, therefore, 3 dots in a triangle means therefore. Get used to that one. It's a really good shortcut. If D is less than 0, therefore no solution. If D is greater than 0, therefore 2 solutions. If D is equal to 0, 1 solution. And if you're extra smart, what's special about that 1 solution? Remember how I circled this and I said if that was all 0, then we'd be left with this. So if there's discriminant of 0, what you're left with is negative b over 2a, which is the vertex. I was hoping somebody would say it, but... Do you get how there's a ton of little things to know? Do you get how having a note card to study for that, like right at the last minute, would be smart? Okay. Your choice, can't make you study from it, but I would think it would help. Okay. Next. Yep. This one? All right. So next, let's say you had to solve a quadratic and it's like got stuff on both sides of the equation. Could you shut the door back there, Keenan? Thank you. How in the heck are you supposed to solve that? Well, to solve any quadratic, you start by setting it to 0. Do that. Now, there's two kinds of kids. The kind of kids that want to move everything on the left over to the right side, and the kids that want to move the stuff on the right side over to the left side. I would just leave it so your lead term is positive. You know what I mean? Like, you have a choice. You can either make the front term be like negative 2x squared, or you could make the front term be like positive 2x squared. I would always try to make the lead term the x squared. I try to leave that one positive. If the front number's positive, it's so much easier. So I would subtract x squared from both sides. Do you have a question still? Okay. I don't even understand what we're doing. We're trying to get this equal to 0. Was there another way you could get it equal to 0? Yeah. But I think it's dumb to have the lead number be negative, so I'm doing it this way. I'm giving all the stuff that was on the left, on the right. No, I'm getting the stuff on the left side to disappear. Now, have I got it solved? No. What's my favorite saying? If you can factor it, you should. If this thing will factor, it'll be so much easier. than the alternative, which is always using the... If you can't factor it, what do? Quadratic formula. The quadratic formula can solve anything, but I would try factoring first, because if this thing will factor, oh, it'll be so much easier. So try factoring it. I don't know if it's going to work or not. I'll find out really quick, though. They have to be pluses, and it has to be 2x and an x. That's the only way it could be. Now, at the end, it could be a 3 and a 2, or it could be a 6 and a 1. And I'm starting to process this, and I'm going, even if I put it this way, it's way bigger than 5. It's 7. If I switch it around, 2 and a 3, then it's going to be 8x. And if I use a 6 and a 1, it's going to always be too big. Dang it, can't factor it. What do? Say it, please. Quadratic formula. Do it. And then you have to simplify your quadratic formulas. Okay, x equals negative b, negative 5, plus or minus square root of b squared, which is 25, minus 4ac, 4 times 2 times 6, all over 2a, which is 2 times 2, which is 4. I can tell already these don't have any common factors, so it's not going to be able to simplify all the way down, but it'll simplify some. Negative 5 plus or minus the square root of, help me, what's underneath the square root? You'll have a calculator, so what'd you get? Nobody's done this yet? Use your calculator, do it. It's 25 minus 48. What's 25 minus 48? Negative 23. That's weird. But that is your final answer. And if you got this far, oh, I would talk to my team about, could we allow this kid to only have 5% off? Because what did they forget? There's one thing you should have done to simplify this. I. Everybody try to write it with an I instead. Would you have anything that hard? Yeah, you're in honors. And this isn't actually that hard, because the cool thing is all you had to know is that you can't have a negative underneath the root. You had to have an I out in front of it right there. Who knew where to put the I? Raise your hand if you did. Okay, good. That's most of you. Okay, so I have been teaching this class a long time, and I know that this skill right here, where it can simplify, is one of the most important ones. So we're going to definitely practice this. This one doesn't, it's actually worse. It's harder because you can simplify it. And so you'd have to. So let's say you did the quadratic formula, you got this. Do you get, because the discriminant's positive, you got 2 answers that are going to come out of this? I'm going to get 2 answers. So what do? I have to know how to simplify it. You cannot take the calculator and go get your decimal answers. Your answers have to have a square root of it. So, step 1, I'm going to have you compare with the kid next to you, and like once you're done simplifying this, why don't you tell them like, I got this, and make sure you're on the right track. Know how to simplify that? And then do you remember step 2 is to factor the top? And once you get it factored, then you can cancel something. All right. This is one of the hardest algebra skills that there is. You didn't have algebra last year, you had geometry, so it's 2 years old. I'm going to pause for a second. Let me simplify this thing down. All right, so back to here. I hope you talked to the partner and you got the square root of 6 and the square root of 4, which is 2 root 6. Raise your hand if you had 2 root 6. Okay, good. Now I'm going to rewrite it. 4 plus minus 2 root 6 all over 8. Can't start canceling yet. Why? Because this is an add problem. If this is an add problem, could I start canceling right now? No, it's an add problem. It would be dumb and think the answer to that is 4. It's obviously not 4. Okay, you can't start canceling in there until you actually get it factored. So you could not cancel that at all. This one, I can factor that. And if I can factor it, I should. 2 gets factored out. And I have 2 plus minus square root of 6. A lot of people put a 1 in front. You can, but it's kind of clunky. And then on the bottom, instead of an 8, I'm going to put a 2 times 4. I'm factoring it so that these will cancel. There's your final answer. Who had it? Raise your hand if you did. Cool. All right. Now, it's got an I in it. Don't be scared. It just acts like a normal variable. Multiply that out. But did you know that if you have one of these graphing calculators, that there's an I button on the bottom? It could multiply it out for you. That'd be really smart. The I button is right above the decimal point. So you literally type exactly what you see on the screen on your calculator, and it would tell you 8I minus 12. Now, couldn't you do that yourself? I could do that myself. How many of you had 8I minus 12? Awesome. But here's the thing. If I multiply that out, 3I minus 1 times 2 plus I, that's going to be a pain in the butt because I got to do first, outside, inside, last, you know, like this. And then I got to remember that I squared is equal to what? -1. Very good, Niven. But a lot of you didn't know that. You should write it on your card. You know, the 3x5 card, I squared is -1. So go ahead and multiply this out. And when you get an I squared, which you will, replace it with a -1 and continue to simplify. If you've got the calculator, it's not cheating to use it. You'll have a calculator on this test. The thing that you would have to do, though, is you'd have to show me this first line of multiplying. If all you did is have the answer, if all you say is like, oh, it's 34 plus I, that's not the right answer. But if you just have the answer, you're not allowed in this class to only have answers. You have to have work. So at least you'd have to show me some work, and then your calculator could check it for you and make sure you did it right. So let's do it. 3 times 2 is 6I. And then personally, I do it in this order. The outside ones are next for FOIL. You know, this was the first one. This is the outside. And that's 3I times I is 3I squared. And then I do the inside ones. -1 times 2 is -2. And then I do the last ones. -I. Put it all together. I have 3I squared. I know, I squared is something special, and I'll deal with that in a second. And then I have a 6I and a minus 1I makes 5I. And then the last thing I have is -2. And you would have been awesome if you got that far, but still wrong. Because you haven't simplified it all the way. Madison, do you have a short-term memory? What's that I squared mean? -1. So that means 3 times -1 plus 5I minus 2 And that's negative 3 and negative 2 makes negative 6 plus 5i. Now remember, I told you this, the real number part is first and the imaginary part is last. We are still deciding, I haven't got a response yet, that whether or not we could mark it right if you have that backwards. Did I make a mistake? Oh, I multiplied them. Sorry. Negative 3 and negative 2 makes negative 5. Sorry, I was multiplying for some reason. That's my one dumb mistake. You know, people do it all the time. You're human. Almost nobody gets the perfect paper. All right, so do you get if you have it backwards? The imaginary part is first, and that's not how you're supposed to write these. They're complex numbers. They have a real part and an imaginary part. The real part is what you lead with. Real part, imaginary part. If you have it backwards, it's either going to be 5% off or it's going to be just wrong. Team's deciding. Okay. So many little things to know. Hard complete the square. Okay, on the hard complete the square kinds. Liam, could you tell me how to start?
Factor out the 4.
Factor out the 4. I get x squared plus x. And then, oh crap, this is gonna be hard. Why? Well, we have to do half and squared. Half of 1 is 1/2. And then 1/2 squared. I know some of you made this 1/4. I wouldn't have. I would just say 1/2 squared because we're in the middle of the problem. Would you agree we're not at the end of the problem? So that's half n squared. Now I'm going to do a 1/4 out here because 1/2 squared is 1/4. And eventually I'm going to have to put that with this negative 11. But now I just made 2 mistakes about that 1/4. Liam, you know one of them?
You got times it by 4.
You have to times it by 4 because this is going to get times by 4. So you're correct. Oh, that's kind of cool. 1/4 times 4 is going to work nice. The other mistake? It's a negative. Yes, because this one's positive. This is supposed to be negative. Then it isn't that bad. I take the square root of 1/4. That's why I think it's smart to just put the 1/2 like that, you know, leave the 1/2 in there, because then you can just take it back out and put it there. And then this turned out really cool. It's just this negative 1 minus 11, negative 12. Do you get, I now have the vertex. Because it's in vertex form, you could ask me what the vertex is, and I'd be like, easy peasy. Vertex, negative 1/2, comma negative 12. And that tells me the axis of symmetry, 2x equals negative 1/2. So much stuff I can know from that. All right, last thing to review. If I gave you this, and I said, does this have real solutions? agree that there's 4 names for solutions. Solutions and x-intercepts and zeros, good.
Roots.
And roots, yes. Well, if I just make a sketch of this, I'm going to know whether it's got real solutions the fastest. In my opinion, that'd be the fastest way. Could I set x, if it's an x-intercept, can I make y equal to 0 and solve it? I could. That'd be really slow, but I could do it. But if I sketch it, -5, -10 is like way down here. And it's an upside down parabola. Now, as you look at it, isn't it really obvious that it does not have real solutions? It doesn't have roots. It doesn't have zeros. It doesn't have x-intercepts. This parabola has not real answers, which means they're imaginary. Do you get that? By sketching it, I was able to quickly tell. So if you sketch a parabola, what if I say it's this? X squared plus 6x plus 7. Can you sketch that? Well, I'd know it was a right side up parabola that has a y-intercept of 7. And I know it has to be right side up. Does that have 2 real roots? No, but I'm not sure. What if it actually looks like that? Then it has 2 roots. I guess I better find the what? The vertex. If I know where the vertex is, and I know the vertex is down here, I'd be able to know for sure whether it has real roots or not. So I'd be thinking of sketches. If I gave you this one, could you sketch it quick? I could sketch it quick. It'd be super easy. And I'd know whether it has real solutions or not. I know it's right side up because there's no negative in the front. Boom. Does it have real solutions? Yes. What if it would have come out like up here? Then no, it wouldn't have real solutions. What if it only touches once? Does it have a real solution? Yes, it's the thing it touched. So they can either touch once, like this, or they can touch twice, or they can not touch at all, like the yellow one. They'll have either no solutions, 1 solution, or 2 solutions. All right. Now, it's not an easy test. There are teachers that are giving the test today, and there's a bunch of kids that are taking the test right this minute. And I thought this extra day of review would help. I hope it did. And I hope that you use that card that I gave you to study. But remember, you can't use the card. If you use the card during the test, it's going to be awful, because then I have to report you for cheating. Your test gets to be counted as a 0, and then we have to have a conversation with principals for your first time offense on cheating. Don't do it. But I think making a card like that is just smart, and I think you should do it for almost every test. Just look at it quick and go, okay, do I remember all these things? Oh crap, I forgot that one formula, and then you remember it quick right before you take the test. It's just being smart. All right. Any other last questions?
Anchor time is now starts.
All right. Perfect. Anchor time starts.